Merging two or more data files in Tableau is really appealing from a visual point of view. Let me try merging together the three data files for the telecommunication data where we're studying churn. So I'm going to go to open up a text file. This data is stored in CSV files. And I'm going to navigate over to where I have the telecommunications data. And so once I'm there, I can just open up any of the data files that are going to be used in this merge. I'm going to open up churn data. And when I do, it lets me know that I have a field for customer ID, how long they've been with the company, some details about the plan they're on, and also their monthly charges, total charges, and whether or not they did or didn't churn at the end of the contract. Now, we've seen before that the other data files, customer data and internet data, talk about some additional customer demographics and also add more details about what sorts of plans they are on. You can always click on the preview to view the data to see what does that data look like. So here's the customer ID, here's some demographic information, and then the internet data, the customer ID as well, and some additional information about what types of plans they subscribe to. So what if we wanted to start with this churn data and add additional information about what types of plans they're on, and then also some demographic data? Well, it's as easy as drag and dropping. I'm going to go ahead and just double click on the churn data. It lets me know it's made of one table right now. And if I want to merge two different data sources together, all I need to do is bring the other data file to the field. It'll automatically connect them together, and in this Venn diagram is your ability to change or modify how that merge is taking place. So I'm going to double click on this, and here are the options. The inner join is the same thing as leaving out that all argument in R. Only customer IDs in this case that are in common to both of these data sets are going to survive this merge. If one customer ID exists in only one file and can't be matched, then it's going to end up being dropped. The left join will say, okay, I'm going to ensure that all the rows in churn data survive this merge, and when available, we'll take the information on the customers in the customer ID file and we'll add that into it. The right join is a little bit weird. It's saying, okay, well, we'll keep all of the rows in the customer data and we'll add NAs, basically, if we find customers in the customer data table that don't exist in churn data. Normally, you should be sticking with inner and left joins. A full outer join, not really used all that often. So I'm going to stick with a left join. I want all of the customers in the churn data file, and then I want to drag in the information about what plans they're on, and I'm going to match up the two data files based on customer ID. You get a chance to say what that by field was in R, essentially how you're matching one table to another. You want to make sure that on the right table over here, that Y data frame, you're choosing the primary key. So customer ID uniquely identifies the entities in that data set. And normally Tableau is smart enough, it figures out what it needs to match by. So we do that and we can scroll left and right and we see that, yeah, great, for each customer, we have the additional demographic information. It also carries with it the customer ID column so you can verify they're the same. We're good to go. All right, let's also add in the internet data. Just go and drag it to the same place. And then it allows us to edit the join. So right now we have churn data and we want to add in the additional information about each customer's churn or each customer's plans here. And so what we'll do is we will join them together with the left join once again, so all the rows in churn data survive. And we'll match up one table to another through that customer ID column. It's the same for both, and Tableau was smart enough to figure that out. So now we have a nice flat file. We have all the information about the customers, and we could start doing visualizations. We can start doing summarizations. So what if I wanted to use this flat file to answer one of my original questions? What is a good guess at the probability that a woman whose value of tenure is at least 36, has been with the company for at least 3 years, and who streams TV and movies, what's that probability that she's going to churn? Well, let's head on over to sheet 1 and build that aggregation. Kind of whittle it down to just the customers of interest and see what fraction of those customers have churned. All right, so number 1, we want to make sure that we're only looking at females. So I'm going to drag gender to the filters and just say, all right, show me just information about females. I also am interested in the people that have done streaming movies. So I'm going to say yes, they've done streaming movies, and yes, they've done streaming TV. And here's where I'd like to put a filter on the tenure that someone has been with the company. So I'm going to drag tenure into filters as well, and we're going to filter based on its value. We want to make sure we're looking at customers that have only been there 36 months or longer. And so now I've basically put it into the subset that I want to consider. Now, how many of these individuals churned and didn't churn? Well, I can go and find the churn column. In order to measure a percentage of different categories, we're actually going to drag churn to both places. And then we're going to say, okay, let's go ahead and measure the count. So in this case, we have 98 people that did churn, that met these 4 conditions, and 539 people that didn't churn. If I would actually like to see those percentages, well, why don't I go ahead and click this and say, let's look at a percent of total instead of just a count. And there we go, 15% versus 85%. If I want a nice table like what I would see in R, I can click on the table in the Show Me, and this gives me a good estimate of the probability that a woman who does stream TV and movies and who's been with that company for 36 or more months ends up churning, about a 15% chance. All right, well, what other tasks have we done in this unit? Well, we looked at Kickstarter campaigns. So why don't I open up a new worksheet in Tableau that looks at the Kickstarter campaigns. So I'm going to connect to the data. It's a CSV file, so it'll be a text file according to Tableau. And I'm going to navigate to where the Kickstarter campaign is. So here's the Kickstarter campaign. It's already a flat file. I don't need to do anything else with it. And so let's imagine we wanted to do an aggregate, like let's measure the percent of the campaigns in each of the main categories that were successful. Or maybe we could measure the median amount that was pledged in US dollars for each of the main categories. So we can head on over to sheet 1. And here is the way that I like to remember it. When we see a blank worksheet in Tableau, it's like a blank plot like what we'd see in R. We have a vertical dimension going up and down, and a horizontal dimension going left and right. Now, if you think of this like a spreadsheet, well, in a spreadsheet, columns go left and right, so columns is our horizontal dimension, and rows, which go up and down in a spreadsheet, is our vertical dimension. So let's analyze actually the median amount that's been pledged for the different main categories. So in this case, if I think about what plot I want to see, or what table I want to see, maybe I want a bar chart where the heights of the bars represent the median amount pledged. So in that case, I want to see left to right the different main categories. I can go and drag main category either to the drop field here, or drag it to the columns itself. It accomplishes it the same way. I've added this as the horizontal dimension. Now, what do I want to see for each of these things? This is like running aggregate US pledged twiddle main category. We'll drag that to rows, the up and down dimension. By default, Tableau loves sums. We want the median. We can change this to measure the median. And if I want a table form to make it comparable to what would appear from R, I could click on the table. So here we have it nice and alphabetized, and here's the median amount pledged for each of those main categories. So what if I wanted to compare the success rates of the different main categories? We did that in R with an aggregate command, essentially aggregate status double equals successful, the word successful, twiddle main category. So how can we do that in Tableau fairly efficiently? Well, I'm going to do something similar to what R does, basically treating trues as the number 1, false as the number 0, by creating a new field. So I'm going to go up to the very top menu, Analysis, and then select Create Calculated Field. And I'm going to say, I'm going to name it Successful, and I'm going to write an if statement. If status equals successful, then I want that to be a 1, else I want it to be a 0, end. And I'll do all capitalizations just in case. I'm going to click Apply. It's added it as a new field here. If I go to the data source, update it, I see I have 0s and 1s for when I have successful or non-successful launches. Okay, so if I wanted to get the success rates of each of the main categories, get those success probabilities, let's do the same thing where we visualize categories going left to right. So I'm going to drag the main category to the columns here. And then I'm going to take successful, that variable I just created, and add that to rows. I want the heights of these bars telling me the fraction of those campaigns that were successful. Now, by default, Tableau does the sum, so this is measuring the number of successful campaigns. I want percentages, I'm getting probabilities here. So I'm going to measure instead the average. If I look at the average of a bunch of 1s and 0s, the average tells me the proportion of the values that are equal to 1, in other words, the proportion of successes. So there we go. I can sort them from smallest to biggest or vice versa, and that's a good way to aggregate in Tableau. All right, another data set that we looked at was the hotel data set. You know, people are booking their reservations over the course of a year. Sometimes there's a higher demand, sometimes there's a lower demand. We looked at this data set as well. So I'm going to connect to the text file, and I'm going to choose the hotel bookings. So I have a nice flat file. I don't need to do any merges. And one thing that we had looked at in R was looking at the average number of special requests among combinations of characteristics. Specifically, what we had done is we looked at combinations of customer type and what type of room that customer had booked. We saw that not all combinations actually existed in the data. So let's do something similar here. Let's go and look at combinations of customer type and also what type of room they wanted to look at, the reserved room type. And we'll put these next to each other, actually one on top of each other. Notice Tableau already anticipates that, hey, not every combination is seen in the data here. But once we've constructed this table, well, maybe we could go and get those averages for each one. Well, what do we need to do? Well, we need to look at the number of special requests. If I drag this right into the middle here, it automatically counts up the total number for a particular combination. What if I don't want the total? What if I want the average? There we go. So very quickly, we've done this aggregation over all combinations of the room that was reserved, the customer type. We've got the average value of the number of special requests that were made. And Tableau very nicely inputs in that these are just missing. These combinations weren't actually in the data whatsoever. And so our aggregation occurred really quite quickly. What else could we do? Well, one of the things we had looked at was the arrival date by month. And we looked to see, well, how did things vary over the course of a year? Notice how much smarter Tableau is than R. It's realized that, hey, these are dates. It's already arranged it in ascending order in terms of time. And so maybe we might like to look at the average number of adults, let's say, for each one of those months. So we could drag adults to columns. It automatically makes a plot for us. We could say, no, we really do want a table. And this would tell us the total number of adults that had made reservations in this data set across months. If we wanted the average number of adults for each month instead, so in January we get zeros if there's no adults for a room, 1, 2, 8, depending on how big a party it is, we could get the average, and we could see how the average changed as well. Probably a bit more visualized in terms of a bar chart, but if we wanted a table like what we had seen in R, that is our option as well.